Every time you talk to ChatGPT, the machine on the other end is doing exactly one thing. Not thinking, not planning, not looking things up. One single task, repeated over and over. Guess the next word. That's it. And somehow, out of that ridiculous, humble task, comes this. Today, we open the box. Here's the whole loop. The model receives your text, the capital of France is, and produces one thing. A probability for every possible next piece of text. Paris, 92%. Lion, 3. Then a token is picked, glued on, and the whole process runs again. And again, one token at a time, forever forward. Let's put a size on that function. GPT, 3, 175 billion parameters, 96 layers. Each token you see it type is the output of hundreds of billions of multiplications. An entire data center heartbeat for the word the. Whatever intelligence is in there, it's not cheap arithmetic. It's arithmetic at a scale with no precedent in engineering. When it answers you, there is no plan of the full reply anywhere inside. The paragraph you receive was born one guess at a time, each word conditioned on everything before it. Which raises the real question of this video. How can next word guessing produce code, poetry, and passable legal advice? The answer lives in three ideas: tokens, vectors, and attention. Part 1. Tokens. A language model doesn't see words, and it doesn't see letters. It sees tokens, chunks of text, usually 3 to 4 characters, from a fixed menu of about 100,000. Common words get their own token. Rare words get chopped into pieces. Watch how this sentence shatters. Why chunks instead of whole words? Coverage. With pieces, there is no such thing as an unknown word. Any typo, any chemical name, any new slang can be spelled out of fragments. It also explains some famous quirks. The model can struggle to count the letters in strawberry because it never sees letters. It sees 2 or 3 opaque chunks. Tokenization even decides who pays more. The menu is mined mostly from English, so the same sentence in Turkish or Thai shatters into twice the tokens, twice the cost, half the context. Where does the token menu come from? It's learned, greedily, from data. Start with single characters. Find the pair that appears most often, say T and H, and merge them into one unit. Repeat the merge 50,000 times, and frequent fragments crystallize into tokens. The alphabet of AI isn't designed. It's mined from how humans actually type. One hard limit shapes every conversation you have: the context window. The model can only attend over a fixed number of tokens at once. That's its entire working memory. Everything you type, everything it replies, accumulates inside that window. Overflow it, and the oldest tokens silently fall off the edge. If a long chat seems to forget its beginning, it literally has. So from the model's point of view, your entire message is just a list of token ID numbers. The capital of France becomes something like, for 91, 7012, 286, 6005. Language, reduced to a sequence of integers. Now, what can a neural network do with an integer? Nothing useful. Which brings us to the beautiful part. Part 2. Vectors. Every token ID is looked up in a giant table and swapped for a vector, a list of thousands of numbers. Think of it as a point in a space with thousands of dimensions. That point is the word's meaning, as far as the machine is concerned. And meaning as position has consequences that still give me chills. Because the table is learned, trained, like every other dial. Words that behave similarly drift close together. Cat sits near dog and kitten. Far away, France huddles with Italy and Spain. The space organizes itself into neighborhoods of meaning, without anyone defining a single one. And directions in this space mean things. Take the vector for king, subtract man, add woman, and the nearest point to where you land is queen. The male to female direction is a consistent arrow anywhere in the space. Paris minus France plus Italy lands near Rome. Nobody programmed analogies. They condensed out of text as geometry. There's a wrinkle. A bag of vectors has no order. Dog bites man, and man bites dog would look identical, same 3 points. So before anything else, Each token's vector gets a positional stamp mixed in, a mathematical signature for I am word number 3. Same word, different seat, slightly different point. Order becomes part of the geometry too. But there's a catch, and this is the problem that stalled AI for years. In that lookup table, every word has exactly 1 point. Bank in riverbank and bank in bank account, same vector. Bat the animal, bat the baseball gear, same point. Real meaning depends on context, and a static table has none. Something has to move these points around based on the sentence they're in. Part 3. Attention, the idea the entire modern AI boom is built on. The 2017 paper that introduced the transformer was literally titled Attention is All You Need. The core move, before predicting anything, let every token look at every other token in the sentence and pull in exactly the context it needs. Take this sentence. The animal didn't cross because it was tired. What does it refer to? You know instantly. The animal. For a machine, that used to be a research problem. And notice, if the sentence ended because it was too wide, the same word would point at the road instead. No fixed rule can resolve that. It takes context. With attention, watch. The token it sends out a query. Every other token advertises what it is, and the match lights up. It pulls the animal's meaning into itself. Attention has a price, and it's steep. Every token attends to every other token, so double the text, quadruple the work. 1 million token context costs 1 trillion attention scores per layer. This quadratic wall is why long context models are hard, why your very long chats get slow, and why a small army of researchers is hunting for something cheaper that works as well. Mechanically, it's a matchmaking system. Each token emits 3 vectors: a query, what am I looking for? A key, what do I contain? And a value, what I'll hand over if you pick me. Scores are just query times key dot products. High score, strong match. Every token then absorbs a weighted blend of everyone's values. That's the whole mechanism. And after attention gathers the right context, a second circuit, a plain feed-forward network, the kind you saw in our last video, processes each enriched token. Then the pair repeats: attention, process, attention, process. GPT 3 stacks 96 of these layers. By the top, bank next to river has physically moved to a different point than bank next to account. Context, solved by geometry in motion. During training, there's one strict rule: no peeking. When the model learns to predict token 5, its attention is masked so it can only look at tokens 1 through 4. The future is blacked out. That's what makes every position in every sentence a free training example. One pass over 1,000 tokens is 1,000 little prediction exams, graded simultaneously. And how does a vector become the final answer? At the very top, the last token's vector, now soaked in the meaning of the whole passage, is compared against all 100,000 token vectors in the menu. Each comparison yields a score. Scores become probabilities. The circle closes, geometry in, geometry out, and in between, 96 floors of context gathering. One more twist: this happens in parallel lanes. Each layer runs many attention heads side by side. One head tracks grammar, another tracks who did what, another watches punctuation or rhyme. Nobody assigns these roles. Like every other structure tonight, they emerge from training. Interpretability researchers still spelunk through GPT's heads, discovering circuits nobody designed. Part 4. Where do all those dials come from? The training recipe is 1 line long. Take trillions of words of text, the public web, books, code. Hide the next token. Let the model guess. Grade the guess. Backpropagate the blame. Nudge 200 billion weights. Repeat a quadrillion times. The internet becomes the answer key, and the model's only skill is not being surprised by it. The price tag deserves a moment of silence. Training a frontier model means tens of thousands of GPUs running for months, drawing the power of a small town at a cost past $100 million to do one thing: lower the average surprise at the next token of the internet by a few more decimal places. That number on screen is the loss curve of civilization's text going down. And now the deep question, why does that create ability? Here's the argument that changed my mind. To reliably predict the next word, you are forced to model whatever process produced the words. To finish, the code throws a null pointer exception because you need to actually reason about code. Prediction, pushed hard enough, smuggles an understanding or something operationally identical to it. You can see it in how ability arrives. Small models babble grammatically. Make them bigger and, without any change in the recipe, arithmetic clicks on. Bigger, translation. Bigger still, chain of thought reasoning appears. These jumps surprise the researchers themselves. Nobody fully knows which abilities the next scale-up will unlock. That's not marketing. That's the unsettling state of the science. What it trains on matters as much as how. Data teams filter the raw web hard, deduplicate it, strip the spam, and then deliberately overserve the good stuff. Books, reference text, working code. The model is what it eats. Feed it forums, get a forum poster. Feed it textbooks and clean code, and the next word machine starts sounding like the internet's better half. But raw prediction has no manners. It will happily complete a question with another question, because the internet is full of question lists. So after pre-training comes finishing school. Humans rank sample answers, and a second training loop. Reinforcement learning from human feedback reshapes the model toward helpful, harmless, honest. That last 5% of training is most of why ChatGPT feels like a someone. Ever wonder why the same question gets different answers each time? Because the model outputs probabilities, not words. Someone still has to roll the dice. That's the temperature dial. Cold. Always take the top token. Precise, repetitive, robotic. Hot. Let unlikely tokens through. Creative, surprising, occasionally unhinged. Every product you've used sits somewhere on this dial. It's also why models hallucinate. The machine is a plausibility engine, not a truth engine. When the real answer is missing from its compressed memory of the web, the most plausible-sounding continuation is a confident, well-formatted lie. It isn't lying. It's doing exactly what it was trained to do, produce text that looks right. Keep that in mind every time you ask one a question. This architecture also explains the little mysteries of daily use. Why does it type word by word? Because it genuinely generates one token at a time. You're watching the loop run live. Why is it better at essays than arithmetic? Text statistics generalize, carry digits don't. Why does think step by step help? Because spelling out intermediate steps puts them into the context window. The model gets to condition on its own reasoning instead of leaping to an answer. And the frontier keeps moving under our feet. Models that pause to generate hidden reasoning before answering. Models that call tools, search engines, calculators, code interpreters, mid-thought. Models that read images and audio through the same transformer core. Every one of them is still, at bottom, the machine you just learned. Tokens, vectors, attention, next token prediction. The wrapping evolves weekly. The engine hasn't changed since 2017. So let's assemble the whole machine one last time. Your words shatter into tokens. Tokens become points in a space where meaning is geometry. 96 floors of attention let every word borrow meaning from every other word. And at the top, one probability distribution, the next token. Sample it, glue it on, run it again. Which means, as a user, you control exactly one thing. What's in the window? That's why prompting matters. Examples in the prompt aren't decoration. The model conditions on them and continues the pattern. Retrieval systems paste relevant documents into the window before your question. System prompts are just text, sitting above yours, steering the same prediction. It's windows all the way down. A detail that surprises almost everyone. When you chat with the model, it is not learning. The weights are frozen. They haven't changed since training ended. Your conversation lives only in the context window, and when it ends, nothing remains. The model that helped you yesterday is bit for bit identical today. Whatever memory products bolt on, it happens outside the network, in ordinary databases pasted back into the prompt. Notice what's not in the machine. No database of facts. No rules of grammar. No logic engine. No memory between conversations. Just 200 billion numbers that compress the statistical shape of human text, and a loop that rolls the dice one token at a time. Everything it knows is smeared across those dials, inseparable and unreadable. And the debate at the frontier is exactly here. One camp says, it's a stochastic parrot, statistics with excellent manners, remixing its training set. The other points at the evidence you've seen tonight. To predict well, it had to build internal maps of meaning, and we can measure those maps existing. Both camps agree on the mechanism. They disagree on what the mechanism amounts to. You now know enough to hold that argument yourself. Is that intelligence? Honestly, the question has stopped being rhetorical. It writes, argues, and codes better than most humans, using a mechanism nothing like a brain. Perhaps prediction was never the opposite of understanding. Perhaps it's the beginning of it. Next in the series, the math behind these machines' training and where the whole stack might go. Subscribe if you want the rest of the story.